Hello, YouTube. This is Umills03. I think I'm going to be on the bottom right for today. In the previous lesson, we started talking about generators, right? And we had actually seen an example of a generator starting in like lesson 9 or 10, I think, when we started talking about for loops, right? And we said basically a for loop is really nice because when we started with a while loop, we had to write something like if we wanted to print the numbers from 0 to 10, you'd have to say y equals 0, while y is less than 10, print y, and then you'd have to increment y. So you could say either y equals y plus 1 or y plus equals 1 if you wanted to use the in place operator, right? And so you'd have to remember to increment y. But then we said it's easier with for loop because you could just say something like for z in range of 5, and then you could go ahead and say print z, and that would be a quicker way of doing the same thing. Okay, but what we said is that range of 5 is not indexable. Okay, so it doesn't return a list. And obviously we've went ahead and done something like print range of 5, and we've said print enumerate of some list, or print map of function and iterable. You know, these are called generators, and so they basically return an object that can be iterated over using a for loop. But if you want to use it in any other way, we said that you have to convert it to either a list, a tuple, or a set, okay? And they yield values, so they can basically be run through in a for loop, but you can't reference the elements directly, okay? So hopefully that's clear to you. So I thought with this video, I was going to actually talk about decorators here in the next lesson, which is actually a way of making a function more enhanced. It's a way of improving its functionality. But I think what we're actually going to do is hold off on that. And I wanted to do just tons of examples with generators because this is actually one of my favorite topics in Python. So we're going to take a look at this example here at the beginning. And I guess in the previous lesson, I said that I wanted to talk about this reverse enumerate method, but this one's a little bit trickier. So I just wanted to show you all kinds of examples in this video and not have it be rushed. Just have only one topic in this video. Although I suppose there's not going to be only one topic in this video because there is something helpful that I thought would be useful to bring up for you guys because this probably could have been brought up in a previous video. But it's a nice way of switching the value of two variables. Okay, so switching the values of two variables, okay? In Java, if we go ahead and assign values to two variables, so we basically, what we would do is we could say something like int a equals 2 and b equals 4. And so what that would do is it would basically declare and initialize two int variables called a and b and gives them initial values. That's how you would write it in Java, okay? In order to swap their values, you need to create a third variable, because what happens if you say something like a equals b and b equals a, you're about to lose information here, right? Because a takes b's old value, right? But now b cannot take b's old value. B takes, you know, a's new value, which is b's current value, right? So b does not get updated. And so the solution here is you would just say the solution, you would say basically c equals a equals b, and b equals c. Okay, so c would keep track of the old value of a. At that point, a would have the freedom to take the old value of b. At that point, b would have the freedom to take the old value of a. In Python, it's a lot simpler than that. So what we're going to do is we're going to say a equals 7 and b equals 10. And we want to know what 10 minus 7 is, but we're not allowed to print b minus a. So what we're going to do is we're going to say ab equals ba. Okay, and so basically what this does is it swaps the values of two variables, a and b. Okay, and so now what we could do is we could say print of a equals, and then let's concatenate it with the string representation of a. And then we could go ahead and say b equals and concatenate it with the string representation of b. And since I wrote this at the top of the file, I think this is probably going to be at the top of the code. So let's just go ahead and run it. Oh, I can't assign I can't assign two values on the same line. Basically, in Java, you're allowed to do that, but in Python, you're not allowed to do that. So I goofed there. So basically what we're going to do is we can essentially now run the code, right? So there's not going to be a problem now. So then it says a equals 10 and b equals 7. So this swaps the values of two variables, and it's a helpful technique for you. And it doesn't just work for integers. So what if you want to swap a list and a tuple of booleans? Okay, so what we're going to do is we're going to say, you know, Python is sick or something like that. And then we could say 2.2, and then we could say not true. and then we could say true and bool of 2, and then we could say bool of 3.5 or bool of empty string. Okay, so hopefully you know how to evaluate those. But then what we could do is we could say B is equal to 6. Okay, now we could just say A, B. So what we did is we redefined, here we redefine A, and that's totally legitimate, and then we can redefine B. So now A and B have these new values, and that's totally fine. Okay, so now what we're going to do is we're going to run A B equals BA again, and then we want to go ahead and see what happens if we say, let's see what would happen. Are we going to get a type error if we say something like B of 0? So let's figure out what the value is at index position 0 of the list B, because we swapped the values of A and B, and it says 5. So it was able to return the value at index position 5 of what was originally A, but what was reassigned to be B. So I think that's enough on that. We have a generator here called define yield 20 randos. Okay, and what it does, in order to understand this R function here, if we scroll up, we don't really see a definition of R. And so what you have to do, you have to think about modules and go back to lesson 16 or 17. Remember, we said that if we write something like from random import randint as R, this means that we will import the randint function from the random module and call it R in our program. Okay, so now, and then what we have to do, remember, what we do is we say rand int of A, B returns a random integer between A and B, and it's inclusive of both endpoints. So it could be the B there on the end, which is not true when we say something like range of 5. But anyway, now you understand what R is going to do. So it accepts 2 inputs and returns a random integer between them. So this is going to return 20. What it's going to do is it's going to say for U in range of 20. So we're basically using a generator within another generator. But you know what? You're familiar with a for loop, right? So what happens in this for loop doesn't actually depend on U. So literally this line of code, whatever, it doesn't matter what U is, but it's going to run 20 times. So this is just line of code. It's going to generate 20 random integers between 0 and 100. Okay, so what we're going to do is we're going to try to print the result of yield 20 randos, and you can actually see it here. I haven't really modified the code, and it says generator object yield 20 randos, and that's not very helpful. So instead what we're going to do is we're going to say for Z in yield 20 randos, we can say print of Z. And so what that does is it generates those 20 random integers that I was telling you about. So you can see the 18, the 66, the 19, 82, 86, 14, and so that's going to do 20 times. Okay, what if I had said range of 5? I'm just going to run it again. Okay, it's probably a little bit easier to see if we have fewer numbers. So 13, 0, 33, 5, and 12. So basically what this happens is that generators do not have to accept inputs. This is true of functions in general. So I think we've seen an example of a function that didn't accept any inputs, but this one doesn't. Okay, so you can just go ahead and call this generator, and what is it output? Well, it yields 5 random integers between 0 and 100, but it's not a list. In order to get a list out of it, you need to say list of yield 20 randos. Okay, if you want a tuple of yield 20 randos, and then you can access elements within. And then every time you call every time you call this generator, it's going to go ahead and give you 5 different integers. Okay, so you would have to go ahead and think about that, right? Because this is going to be random integers. Okay, so if you're going to go ahead and, what if we call this again? Let's just go ahead and copy and paste this code and see what happens. Let's see if we get the same 5 numbers twice when we run it, and we don't. We get 10 random integers. Okay, so hopefully that makes sense to you. And we already talked about the yield 5s, right? And we said that we could just go ahead and yield as many 5s as whatever X is. So this is an example of a generator that accepts an input. One of the things we didn't really talk about is the doc strings for generators. Okay, so do you say returns? Do you say generates? Do you say yields? The question is, I kind of looked online for it, and it doesn't really seem to be a big deal. It doesn't really seem to be a big topic of contention in the programming universe. But I think if you say generates, or maybe you could say yields. Okay, but regardless, remember what we said is that if you go ahead and scroll over the name of a function, it goes ahead and gives you a description of it. So hopefully that makes sense to you. And this just yielded 5s, right? So I think we already talked about that enough in the previous video. If we say print yield 5s of 3, we get the generator object, right? If we say print range of 10, we get range of 0, 10. But then we can get list of yield 5s of 3, tuple of yield 5s of 3, set of yield 5s of 3, and those look a little bit cleaner. Okay, and then we have generate 2 of each, and I think we already talked about that enough in the previous video. But what does it do, right? If we try to print the generator objects, this is what we get. If we try to print each of the elements in that's, you know, yielded by the generator, then there's no problem with that. And then we could also try to print what is it, a list of t, right? So you could just go ahead and say print list of t. I think in the previous video we tried printing the tuple version, right? And so then you could go ahead and see a list of those 8 elements. Okay. Let's think about the reverse enumerate method, reverse enumerate function. So we already described this a little bit, but remember that if we remember enumerate of list is a generator. So if you basically pass a list, or I think a tuple would work as well, into the enumerate function, what it does is it generates tuples, okay? And each of the tuple, then there's one tuple for each of the elements that you passed into the list, that you passed into the generator, right? So if the list that you passed in has 8 elements, you're going to get 8 tuples. Each of those 8 tuples is going to have only 2 elements. The first element is the index position, and the second element was the element, in the list at that index position. So remember, if you were passing in a list, it would be a tuple. It would generate tuples: 0, list of 0, 1, list of 1, 2, list of 2, 3, list of 3, and so on all the way through. Right, and so what we're going to do is we're going to return tuples where we actually do list of 0, 0, list of 1, 1, list of 2, 2. So we want to return similar tuples, but we actually want to get the element at that index position first, and then the index position. Okay, and that's just for fun, but I want to show you one way to do that. One method is you could say enumerated list equals list of enumerate of some list. So then what would this do? This would give you the list of tuples from, list of tuples of, the index element pairs from the list, right? And so that's just a list of the enumeration. So hopefully that makes sense to you. And then we initialize an index position variable to be 0. That's pretty straightforward. And then we say, wow, that variable is less than the length of the enumerated list. And what we could figure here is that the length of the enumerated list, how many tuples are there going to be? Well, that's just going to be the length of the list that you passed in. Okay, so that's just going to be however many elements you had. You just get 1 tuple per element. And then you could say current tuple equals enumerated list of index position. So this basically assigns current tuple to the tuple corresponding to that index position, right? So you would start at 0, right? You would start at 0, right? And then you would go all the way up to, the length of the list minus 1, but you're looking at a particular tuple now, okay? And you have to think of that as an element in the list, okay? You have to think of that as an element in this enumerated list of tuples. Hopefully that makes sense to you. So current index position is current tuple of 0. So now what it does is it references the index position within the tuple. So this is for a particular element. But that gives you the current index position that you're on. And then if you reference, the index position 1 of that current tuple, that would give you, the current element value. So hopefully this is sort of making sense to you intuitively. And if it's not, you should rewind a few videos and remind yourself what the enumerate generator does. So then we're going to have tuple to yield. And then what we're going to do is we're just going to pass those 2 values in, but we're going to do it in reverse order. So we're going to put the current element value in first and then the index position. And that's going to be the tuple to yield for that particular index position, for that particular element of the list that was originally brought in to the reverse enumerate generator. So that's a mouthful. But now you can say yield, tuple to yield, and then you're just going to increment the index position by 1. So what's going to happen the next time around? Now current tuple is going to reference the next tuple in the list of tuples, okay? And then it's going to get different. These values are going to be different because of obviously the index position is going to be different. Now instead of a 0, this is going to be a 1, right? And then this is just going to be the element that was at index position 1, okay? And the next time you go through the loop, this is going to be a 2. And this is going to be the element at index position 2. And you're going to keep doing that, and you're going to yield all the values until this while Boolean is no longer true, until index position makes it to the length of the enumerated list, the length of the list that you passed in, and then you would know that you're done generating tuples. So we have 5 minutes left. just to say the other, so hopefully this makes intuitive sense to you, and I tried to walk you through it, but yeah, you can put questions in the comments, I guess. The other approach would be to convert each of the tuples from enumerative V to a list. Okay, so what you could have done is you could have grabbed the tuples in enumerative V and you could have converted each of them to a list. And then we know how to basically switch the index positions of two elements in the list. So we just learned how to do that, right? You could have said something like list of zero, list of one equals list of one, list of zero. And here list refers to, list refers to basically, for each element, it's that index position and the element there, okay? And so we think of those as tuples coming out of the enumerate, but what we're doing is we're saying that you can convert each of those tuples to lists, okay? And then you would be able to switch their values, and then you would be able to convert the list back to a tuple, and you could yield each of those tuples, okay? So that's a slightly different way of doing things, but hopefully that gives you an idea. So then I guess I can scroll down the code here. I don't think I changed too much. The reverse enumerate, we try to print a reverse enumerate of 3, 9, 1, 2, right? And then, so what we wanted to do is we wanted to basically see, we wanted the goal here, I guess the naive student would think, oh, the generator just is able to return a list, right? So what would we get? We would get 3, 0 in the first tuple, and then 9, 0, or 9, 1, right? And then 1, 2, and then 2, 3, because we do the element and then the index position. But in order to get that result, we need to say print list of reverse enumerate of that list. Okay, so hopefully that makes sense to you. Okay, and then we also could have yielded the tuples from it. Okay, so now we could have also said for item in reverse enumerate of, and then you could say 3, 9, 1, 2. We can use the same example. And then you just would just basically say, you could say print of item, okay, and then it would just go ahead and give you the tuples according to how we define the generator. Okay, so we would go ahead and make sure that our parentheses are balanced here. Maybe we have too many, so hopefully that's clear to you. And then we can go ahead and run main.py, and then we can go ahead and scroll up. So then we go ahead and get the reverse enumeration. So hopefully that makes sense. We just have, how much time do we have? So 2.5 minutes. The no input generator, this is just another example. So I think we already sort of talked about that one. What about generate X? So there's going to be one more example here that we can do. So generate X of X and Y. So this generator accepts 2 inputs, and you can have documentation for this. So don't forget your documentation. This generator, you would say accepts 2 inputs, X and Y, and yields X. Y many times or something like that, and then you would have to go ahead and specify the parameters and what it yields. So X would be the number to yield, and Y would be the number of times to yield X. Okay, and then you would also go ahead and say something like yields or generates. Okay, and then you could go ahead and keep filling this in, right? So we're kind of running out of time here, but this would be generates, and then you could generate, X, Y many times or something like that. And then, so this is what it does. It says Z equals 0, while Z is less than Y, you would just yield X, okay? And then you just increment Z. So it just yields X, Y many times. And this is the formulation for it. So if you wanted to say, and it doesn't even have to be a number actually. So then if you're thinking about yielding something, I guess the point here to make is that you don't have to yield a number, okay? You can think about yielding other data types. You could, on your own, you could think about trying to yield a tuple, okay? You could think about trying to yield a string, okay? Or a dictionary. You could try that out on your own. But then with this, so this would accept the 2 inputs, right? And so if we say for S in generate X of generateMe and 5, this is going to be yielding the string 5 times, right? And then if we go ahead and print that, we see that. But then obviously, if we had said print generate X of generateMe of 5, you can predict what's going to happen here. So we can go ahead and run the executable file, and it just calls a generator object. And obviously we would fix that by basically we can make a set out of it. And then that would, what if happens if we make a set out of it? So this is kind of interesting. So we've been making lists and tuples out of the results of generators, but what if we make a set here? So now we would just go ahead and have a set with one generateMe element in it, because we said if we're yielding the same thing over and over again, then a set would only have one element because no duplicates are allowed. So hopefully that was interesting. In the next lesson, we're going to talk about decorators and how to enhance our functions within them. So from UMills3, thanks for watching, and please subscribe.